When I graph y equals the square root of x, I always go back to the old-fashioned way of starting of how you learn to graph. You guys all started to learn to graph by creating simple tables. But I'm not going to make a table here. I'm just going to say the table. If x is 0, what's the square root of 0? 0. What's the square root of 1? So at 1, it's 1. What's the next perfect square? 4. The square root of 4 is 2. And so on and so forth. So the graph of a square root function is going to basically look like that. Okay. I'm going to reintroduce a couple of terms here. What is the domain and what is the range? What does the domain stand for? You guys remember?
Yeah, like between like 0 and
The x values. I heard someone say the x values. Yes. So the domain is your x values, therefore the range is the
y.
y values. And the easy way to remember that is? What comes first in the alphabet, domain or range?
Domain.
What comes first in the alphabet, x or y? There we go. So in this example, my domain, what are my values of domain? What is the smallest value of x here? Can it be anything less than 0?
No.
Can it be 0?
Yes.
So my domain is going to be x is greater than or equal to 0. What about range?
Same thing.
Say, in this case, it's the exact same thing. The range is going to be that the y values, because we're talking about y, is going to be greater than or equal to 0. All right? Now, what we do here is that we start to move stuff around with a vertical, or excuse me, an amplitude, an a value. When you're talking about a, h, and k, and we've seen this before. Remember we did that with absolute value? The a value raised the slope or lessened the slope, make it wider or skinnier for the absolute value. Kind of does the same thing when you have your a values in front of the radicals, when you're nth root things. That will tell you how fast it's rising or how slowly it's rising, whether it's moving up and to the right or it's moving down and to the right, depending upon if it's positive or negative. So let me show you how this starts to look, because that's what we start to build off of. Same idea, y equals, let's say it's we'll start with 2 square root of x. What I'm doing here again is just tacking on an a value. This is mirroring the following. A root x, where that value of a is allowing us to either raise the curve quicker or slower, however you want to put it. Again, when I go to graph something like this, I start with those same 3 points. When x is 0, what's the square root of 0?
0.
What's 0 times 2?
0.
When x is 1, what's the square root of 1? What's 1 times 2?
2.
So that means now at 1, it's at 2. No, it's just getting different ordered pairs. And again, at 4, the square root of 4 is 2. 2 times 2 is 4. So it's just right. It's just ordered pairs are different. That's all. All that a value is just multiplying it by some factor. Okay? It's changing the ordered pairs. And the reason why we bring that in is because we get this generic form of a shifted root problem, a square root problem. And it looks like this. Y equals a x minus h plus k. Where your h's and k's stand for your horizontal and your vertical shift again. Horizontal moves left and right, so you're changing your x values. Your k values move up and down, so you're changing your y values. So when you have a problem like this, it'll ask you to graph y equals negative 2 square root x plus 1 minus 2. And we're going to graph that. And there's a very simple 2-step process. Well, okay, sorry, 3. Yes, ma'am.
Not like as difficult as we'll get
Yeah, the graphing of these things are pretty straightforward.
Okay.
The chapter 9 graphing is a little bit tougher than this. So again, first thing I want to do is just label what my A, H, and my K is. What's my value of A?
Negative
Two.
2.
What's my value of H?
Negative 1.
Good, glad you guys caught that. The generic is X minus H, so it's always the opposite sign. And then since it's plus K, it's always the same sign. So here my K value is negative 2. So that means when I shift this, since my H value is negative, which direction am I shifting it? Left or right? I'm shifting it to the left. So it's got to go to the left. And this is telling me that it has to move down. So we've done the first thing. The second thing is to plot. We're going to plot the parent function. The parent function is just the a root x. And in this example, my a root x is negative 2 root x. So I start by plotting that, just like we did a second ago. I'm going to use those 3 points, 0, 1, and 4, as my x values to try for my domain, and substitute in. So what's the square root of 0?
0.
What's 0 times negative 2?
0.
0. So it's still at 0, 0 to start with. What's the square root of 1?
1.
What's 1 times negative 2?
And negative 2.
So instead of moving up, I'm moving down. And now, what's the square root of 4? And then what's 2 times negative 2? Good. So at 4, I'm at negative 4. So I've got my parent function, and I'm going to graph this with a dotted line. Because it's not the real graph, it's the pre-shifted graph. When I do the shifted graph, it'll be a solid line. And you're going to see this a lot into second semester when we graph these. So that's what my parent function looks like. To that, yes,
So why did you have multiply by negative 2?
because that's the value of A. You always multiply by whatever the A value is to get what's called your parent function. And then from there, you're going to shift everything left and right, up and down. In this case, I have to move everything to the left 1 and down 2 spots. Then I would create that with my solid line. So the last step is to shift. So I start at 0, 0. If I have to move it left, I move it left 1, and I go down 2. I'll change colors.
Why can't you just do this?
What's that?
Like, why can't you just do this
Because this is how they always show it. Because when we get further along, we start graphing trig functions, you're going to want to graph parent functions. I'm just getting you guys in the habit of graphing the parent function. It makes your lives so much easier later. Yeah, H and K. That tells you for every point you're going to move to the left 1 and down 2. Whatever your H and K values are, that tells you which way you're shifting.
So whenever you have like this y equals a, like this type of
Yeah.
thing, you can do y equals a and sometimes you do the shifting.
Yeah.
Oh.
You always do that first. You always plot the parent function first and then shift each point. So now I go to the next one. I have to move it to the left 1, down 2. Move to the left 1, I go down 2. And I make this a solid line. Now, what is my domain and range? What is the smallest possible value for x that you can have?
0. No. -1.
At negative
What
1.
am I saying?
My domains has to be greater than or equal to negative 1.
Less than or
What's that?
less than?
Greater than, because I'm still moving this direction. All right. And then my range, what's the highest value of y?
To -2.
Negative 2. So it means my range is going to be less than or equal to negative 2.
So the parent function is the one black and the
Yep.
regular one, so you just take h and k and shift them.
Yeah, so when you shift it, you make solid.
So that's not like the real
So,
function.
Yep, but that's the real one.
is the domain
From the shift.
the graph?
It's always from the shift, yeah. Your parent function is always going to have it starting at 0. It might be less than or equal to for the range, or it might be greater than or equal to the range. It could be going depending on what the a value is. A is negative, it's going down and right. It's positive, it's going up and right. It just depends on that. But it's always you list your domain range after your shift. Okay?
But you list it from the
Correct. Always from the shift. Yep. So that's what this stuff looks like as far as the square roots are concerned. The only thing that changes when you do the cube root is that you have a cube root function.
Oh.
You still only have to really worry about 3 values, and they're very, very easy values to work with. Okay? Can I go to a clean one and do a cube root?
Please.
So if I start with the cube root function of y equals, well, let's just look at what the cube root looks like to start with. Again, just to start with, I'm not putting any amplitude change to it, I'm not giving it an a value, it's 1. If I just want to graph what the cube root of x looks like, start with something easy. What's the cube root of 0?
0.
0. What's the cube root of 1?
1.
Can I take the cube root of a negative value?
Yes.
Yeah. So what's the cube root of -1? -1. Bless you. Now, after 1, what's the next perfect cube root? 8. Excellent. 8. So all the way out here at 8, the cube root of 8 is 2. Do you agree? All the way out over here at -8, the cube root is at -2. So you get this idea of that the graph is going to look like this.
Crazy.
So when I'm looking at a cube root function, is there any restriction upon my domain and range?
Really never is.
Why?
Because negative works too.
Yeah, it's continuous. It works from negative infinity to positive infinity. There's no break. There's no low spot. There's no high spot. It's approaching positive infinity as it's getting larger and larger, and so on. Going either direction. There's no stop point that it cannot work. Yeah.
If it was what's the one with the cube root?
Fourth root.
Fourth root, it would be able to.
There would be a.
Even again?
Yeah,
So
exactly.
there'd be another domain and stuff.
So what I'm saying here, guys, yeah.
So when you plotted, you did cube root of 0, and then what was the next one you did?
1 and -1.
1 negative.
1 and -1. And you're not going to have to use the 8 on these. I just wanted to show you guys that it's just tailing itself out. That's all. I'm just going to say use plus, minus, 1, and 0 for these things. When you're doing the square root, use 0, 1, and 4 because it's very, very fast. 3 points. Really all you need to look at. So when you go into something like this, when you have a shift or an a value, like a parent function, we'll put that one over here. Let's say it's y equals -2 cube root of x. Let's say I'm going to look at that. All I'm doing is changing the a value. And when I want to look, see what that is, I use 0 to start with again.
Everyone's saying it ends up 0.
I'm going to have to agree with you. It's not often that I do, but I will.
Oh. Is that a challenge?
Now I use 1. What's the cube root of 1? 1. And what's 1 times negative 2? Good. Now, what's the cube root of negative 1? Negative 1. So what's negative 1 times negative 2? Positive 2.
Oh, well, switching directions.
So this is going to be like that. It's just going the other direction. One of the things you'll notice is that when you just have the parent function, just an a cube root x, your 1s and negative 1s are going to have opposite sign values. They're going to have the same values, just going to be opposite signs. That's why making graphs of these is really, really straightforward. So let's shift it. What do you think you have to do to start with?
Y equals 3. You do that.
Again, this is following the pattern of y equals a cube root x minus h plus k. So if I have y equals 3 cube root of x plus 2, all minus 3. Just like we did with the square root function, I want to label out what my a, h, and k is. What's my value of a?
3.
3, good. What's my value of h?
Positive 2.
Negative 2, good. And my value of k?
Negative 2.
Very good. We're going to plot the parent function, dotted. Always plot the parent function first. Use those same 3 points, plus, minus, 1, and 0. What's the cube root of 0?
0.
0 times 3.
0.
What's the cube root of 1? 1 times 3.
3.
And then you get negative 1, and then you're at negative 3. So when you draw this out, remember it's going to be a dotted line. There's your parent function. To each of those 3 points, where are you moving them?
Left 2, down 3.
Does everybody agree with that? So now I shift left 2, then I'm saying negative 2, negative 3.
Yeah.
So if I start at 0, I go left 2, and I go down 3. If I go to 1, I go left 2, down 3. And then here I go left 2, down 3. And there's my real graph. Is there any restriction upon your domain and range?
Yeah.
Nope.
No.
The worksheet, always. Yeah. All right, so again, this is a cube root function. Do I have to worry about any domain and range restriction?
You don't.
Is everybody okay with understand? We all understand why? No?
Sorry. You can tell you exactly.
Okay. Again, when I'm talking about my domain, are there any values of x that won't give me a cube root here? Is there any break in that graph? No, so there's no restriction. So my domain is all real. Look at my y values for the range. Is there any restriction on the range? Is there like a high point or a low point? So there's all real numbers. That's what that means. The difference between the cube root and the square root function, the square root function starts at one spot and it goes a direction.
Oh, yeah.
So that means there's a bottom and a side. If that makes sense. Yeah.
But you don't need to write it.
It'll ask you about domain and range.
But all you need to say is the whole number.
Yeah. Yeah, for these things you just say all real numbers for that one. If it was, like I was just saying, if it was a square root, you'd have to figure out where is that low point or that high point, in what direction, that's all it is. Okay. Scary?
No.
You wanna try two?
Scary.
Alright, let's see. Try those two real quick. Like I said, do you want me to walk through either one of these? Which one? Which one?
I just need one of them done.
All right, we'll do the square root one because we just did a cube root. We'll try the square root. So the square root one, I have an a value of -3, h is 2, and k is 1. So I start my parent function. I have 0, 0. At 1, it's -3. At 4, it's 2, -6. So it looks like this. To those 3 points, I'm going to move them to the right 2 and up 1. Right 2, up 1. Right 2, up 1. Right 2, and up 1. And there's my new. With the square root, what's now my new domain?
X is greater than or equal to 1.
Read it again.
2.
2. X has to be greater than or equal to 2.
Wait.
And what's my range?
Oh, I did those opposite.
My range
Less than or equal to 1.
is less than, y is less than or equal to 1. Because that's kind of the stop point. Okay? Now, explain the explanation of the assignments that I've given you. On those 2 separate sheets of paper that I gave you guys, you're going to find that there were 6 graphs on one of them, 6 graphing problems on one of them, and I think 4 graphs on the other. So I want you to definitely get all the graphs done for homework.
We only got one.
The other ones, you guys didn't get the other one?
I found that other
Yeah, see, look at these
I guess I
guys.
don't have to.
So then with the rest of this stuff, you'll notice it's a whole bunch of review problems. I would, after I get all my graphs done between these 2 sheets, bless you, I would then start working on all the rest of the problems because that way I can get ahead to prepare for, we're going to go through a lot of that tomorrow. You guys have been struggling with your exponent rules, and I'm going to be working hard on going over lots and lots of exponent rules tomorrow. So get the graphs done, and then go into the rest of it, as much of it as you can get done, okay? Yeah, there's like 10 of them total. It won't take you very long, okay? I would look at graphs, and I would look at my exponent rules problems, and then we'll continue with solving equations and stuff like that later. Yep, there are 6 problems that have graphs. On that stapled sheet, those are all the answers. These are the problems. All right?